Hello everyone, I'm Gaurav Sharma and I will be your host for this webinar. This webinar is a part of Firstgreen Webinar series, and First Solar Power India has sponsored this and we are very thankful to them. First Solar has about 8 gigawatt installation globally, and they are also identified by the market as the best quality thin film module manufacturer in the world. Now about Firstgreen. Firstgreen is now a renowned name in the field of solar PV. We provide diversified services to our client, which majorly includes the project management consulting, the detailed engineering design of solar PV plant, lenders, engineer, project financing. So our role is majorly for the providing a consulting services to advise our client to for each and every part for a solar power plant, right, starting from conceptualization stage to post-commissioning plant performance assessment. Now, before I introduce you all with the topic and our speakers, let me present a bundle of thanks for huge appreciation for our previous webinars. Now let me introduce you with our topic, which is solar plant layout strategies. As we all know, India is moving toward the ultra megawatt scale solar power plants. This becomes extremely important to define our plant layout strategies right away. In this webinar, we will discuss the issues like array designing, module stacking, the comparison between portrait and landscape, impact of shadow, their quantification as their losses and all. And to share this knowledge, we have two dynamic personalities of solar industry. First, we have Dr. Sanjay Vasishtha, the CEO of Firstgreen Consulting with us. He has provided its consulting services to more than 200 megawatt capacity. Solar market appreciate him for his tremendous knowledge. Secondly, we have Mr. Suhas Suthar, the head engineering from Mahindra EPC, a top EPC company in India. He is technically very strong and will share his some experiences with us. Now, before I call Dr. Sanjay on air, I would like to make some announcements regarding this webinar. The PDF copy of these presentations and the video file of this webinar will be available on Firstgreen website for the download, and we will also share the direct download link with all the participants. You can ask your queries while we are during this webinar. As you can see, here, there is a chat button where you can write your queries, and we will upload the answers of your queries on our website. Now, not taking much time, I would like to call Dr. Sanjay on air, and please, Dr. Sanjay.
Thanks, Gaurav, for the introduction. I welcome Suhas as well as a co-speaker in this webinar. And we have been working together on various projects while Mahindra was EPC, and we have been as a project management consultant. And at times when we start the project, the first question comes is there's a land, and how should I do best utilization of this land for installation of the plant. And at times it becomes critical. For example, if you can see in this picture on the cover slide, the modules are stacked in a portrait manner, one over other. You will find many cases wherein the modules are stacked in this fashion or in the landscape fashion, single stacking, double stacking. we would not like to comment that this is better or that is better, because if you are adopting one layout, then you have to take care of the subsequent effects associated with that layout to optimize your design. Each design can be optimized. At times there are constraints, there are land constraints which force you to adopt certain layout. At times there are shadow constraints which force you to adopt some different layouts. But generally, now let me take you further in this. Okay. So typically in a plant, what you have to have is your DC side, which is the solar modules. Then these solar modules are connected to the inverters, and finally there's a AC side where in transformers, and finally you are feeding. So this is a typical solar plant structure. And in this section, what we are focusing is only on this aspect, that how you can best utilize your layout and how you should do the land utilization planning and what are the options you will have. I would widely cover the different options for installation, but to the deeper side you will be taken by Suhas. So you can have a particular solar PV plant structure in various fashions. Suppose the plant is of larger size. For example, this is a snapshot of some 30 megawatt plant, and what we are finding is these blocks, which are representing something like 1.6 megawatt each block, and this design had the string inverters, so you are not finding an inverter in between. The modules are spread in kilometers, and it is not only the shadow or the inter-row distance. You have to consider a lot of factors, including the slope of your land, including the road you want to plan. You have to provide, and probably you have to take certain symmetry in your design. So we are going to see some of those designs which affects. Before we go to those designs, there are, when you start, you will be first associated that how do I select my structure. And again, there are various options, as I discussed previously, that the structure can be accommodating some portrait layout or landscape layout. You have to see how much should be the pitch, how much should be the tilt angle, which will be taken by Suhas in his presentation. These are some other layouts for the thin film. You can see how the installation is done and stacking of one module over other. These are rather larger. You will find these type of stacking almost 5 times stacking as well. At times you will be having an option that in a single land you are supposed to install a thin film as well as crystalline, and the thin film module is of smaller capacity in terms of wattage, and crystalline is of larger capacity, and you have to manage two things together. For example, in this photograph also you can see this is the thin film, and this array, if you see, this is a crystalline module. So managing that becomes a tedious issue because your modules are only changing. Rest of the things you have to manage at the same pace. At times you have to take care that if the wind speed is very high on that side, you may be keeping the tilt angle on the lower side. this will obviously reduce your generation, and for that purpose you have to decide that how you should do the stacking. This is again one example, as I was discussing, the landscape installation with 4 stacks. You can see 1, 2, 3 and 4, rather 5 stacking. 1, 2, 3, 4. 4 stacking, 5 stacking is there in this design. So you will have various variations in the design, and you have to optimize those designs. Now let's examine some of the plant layouts which are already installed. I've taken these images through Google Earth, and what you can see is that in this layout you are having the large plant, and the inverters are placed in between of different sections. Now centrally placed inverters help you out. Why? Because the DC lines which are coming from different modules are coming right up to this center. So all these 4 solar fields are feeding energy to these inverters. Similarly, in this section, again, all the modules are feeding electricity to this inverter, and this is how your DC length is optimized. This is one of the way. You can also see that they have provided an approach road, a central division, and finally there are approach roads up to the inverter, but in between of the module there are relatively smaller distances. If you look at this design, you will not find any inverter. In fact, inverters are there. If you look closely, here are the inverter room, here are the inverter room, here are the inverter room, and here are the inverter room. There is no central division, and there are no, you can't see, a little bit of peripheral road you can also see, which is the only approach road which is connecting these inverters. Now what is happening is, suppose this inverter, it is also getting feed of DC electricity right from the extreme down panels which are over here. Also you can see is, this is the south side, okay, and the location of inverters is kept on extreme north, and here. So what is happening is, you have to, this inverter room will not put too much of shadow on your solar fields. But the problem is, if you want to clean your modules and take the tractor or something, the approaching for such a smaller distances will be difficult. Maybe you have to put hose pipes, or you have to put a water arrangement in your solar field. Again, in this design, generally we emphasize on the central division of any field. What will happen is, if you have a central division like this or this, it will allow you to the easy access of the plant. Lot of things can be simplified. You can compare, there is a symmetry, so generation also can be compared from one field to the another field. So you can do a lot, but at the same time you should have that type of land. At times there are land constraints. Land may not be truly oriented towards north and south. These are some more designs I would like to share, which are without symmetry, but still they have tried to make certain blocks, and each block is feeding the inverter. Here also you can see this and this block, the inverter is beautifully kept at a place where from, but if you see, the extreme distances may not feed this, and probably here also they have kept one control room wherein one inverter is also taking care from this section. While we were doing this analysis, we realized that some of the plants are not oriented to the true south. Now look at this. This is the plant which is true south, and this is the plant which is not towards the true south. Now when you are starting, you have to see that the true south is located through an engineering study, and you have to have specialized instrument to locate the true south first on your ground, and then you should do the layout planning. If your plant is not oriented towards true south, means it is having certain angle, azimuth angle. If it is true south, azimuth is 0. So as you move away from your south, your orientation, what will happen is your losses will increase, and these losses are just because your plant, your panels are not truly oriented towards south, and it may affect the generation throughout the life period, and it is a mistake which cannot be corrected in future. So it is very, very important that you locate the true south of your location. As I discussed, having a peripheral road or a main division road, both options have been practiced by the plant developers. If you are doing a peripheral road, then taking out the wires up to the module is possible. However, you have to take care of not only the electrical side but also for the drainage. So if you have the central road, then you can collect all the drainage and bring it out. But if it is peripheral, then all the drainage has to be taken out to one side. Now you have to see how your plant is sloped. So that makes a very, very important factor, that how you design your stormwater planning as well. So planning a solar plant is not only planning the layout of the module, but equally it is important that you do a good stormwater layout planning. This is the plant. Maybe Suhas can explain more about this. This is the plant layout design done by Mahindra EPC only. And you can see it's the plant in which we were consultants with them, the JK Lakshmi plant, and the land was not oriented to the north-south, and it was a diagonal land, and using a diagonal land was a biggest challenge. And what you can see is we have tried to manage the true south. There are central division of the plant. You can see half plant is like this, half plant can be like this, and the inverters are located in the central. So when you do this, you have to do the DC loss analysis of your plant, and this loss analysis has to be done, that how much in each design configuration you have the length of the DC wires, how much is the so once you have those lengths for different configuration, you will come to know that in this configuration the losses are minimum. And it is not only the length of the DC wire or the DC losses, but equally it is also important that you also analyze the shadow losses, because if you don't keep an adequate distance between the two arrays, then it will lead to the shading of one array to the another array, which needs to be taken care. As I discussed, that if you have the portrait and landscape design, so what will happen is, suppose this is true south, here you will get the shading. If this is the true south, this array will put shadow in the morning hours to this side, lower side, and it will cover the strings of individual modules on this side. On this design, probably it will be giving shadow on this. However, only one string of each module will be subjected to shadow, and obviously here you may get a better generation, but here you can have a better land optimization. There are various options. That's what I'm saying. I'm not concluding still. In portrait design, when you connect the one module to the another module, and like this, you need to have a home run cable. So in this design, if you have a home run cable, the home run cable will be smaller as compared to a design which is like this, which will increase your DC losses. So there is a need. It's not a direct answer. You will have various factors, and you have to do optimization of the factors like your length of the cable, your shadow losses, your module performance, okay, your distance of inverter, your ease of convenience, installation comfort. So there are various factors which are taken into consideration. Then only you finalize a design, and one design cannot be replicated to the another part. At times you will see that some people just do one design and they keep replicating, and they end up doing one mistake repeatedly to various projects. So it is important that you analyze each plant with scratch and don't replicate the older designs. Rather, you should learn what were the mistakes done in the previous design or what are the possible improvements done in the new designs. I will be available still. Let Suhas start his presentation because he is covering to the deeper side of this shadow planning and inter-row distance analysis, pitching, and how you should decide that. Maybe Suhas can also comment on some of the issues which I have raised. I would welcome some of the questions which you want to ask. You can put in your chat box as we highlighted here. There is a chat box in which you can put your questions, and we will be happy to answer those questions at the end of the session. You can also send email to us at sanjay@firstscreen.co. Suhas will also share his email at the end of his presentation, and we will be happy to answer those. Thanks. I would invite Suhas. Sheelam?
Hello. Thank you, Sanjay, for your presentation and introducing me to this sessions on sponsored by First Solar on this solar plant engineering. So I would be taking you through the solar plant layout strategies in terms of two parameters, which are like optimization of tilt and pitch and shadow analysis. Before going or starting my presentation, I would like to talk something about what where Sanjay has left, like true north. So it is quite important to check true north before starting the array layout, and as in practice in MAPC also, we do this meticulously or religiously, because you know always there is a difference between true north and magnetic north, because whenever you take north from magnetic compass, it is generally 9 to 10 degrees deviating from the true north. So we recommend to do this alignment, north-south alignment, using high accuracy DGPS equipment. Regarding roads and drains, it is very much important to have access to your control rooms or inverter stations for future maintenance perspective. If in case of any failure, you need to have roads at least 6 meter wide approaching to these main rooms, so that in case of failures, your big trailers or trucks can access to those control rooms. And you should have good quality of roads. Like, means if you leave it to the normal earthen roads, it may affect in case of monsoon. The rainwater can affect the roads. Then regarding access to the module areas or to the module strings, it is also important from module cleaning perspective, because during maintenance, if you soiling is a major problem in India, and you will have to keep sufficient gap between two rows to have access to these module rows. Like sometimes people do cleaning using water pipe network throughout the plant, but which seems to be very costly, And secondly, the water issue, means most of the plants are being put into the barren land areas like Rajasthan and Kutch in Gujarat, wherein water is a very precious commodity. So So you need to have kind of a tanker kind of thing which moves between these two rows. So you have to keep plant space between these two rows to have access for module cleaning. Then the other part was landscape and portrait, which Sanjay was talking on. So there are, as Sanjay told, there are numerous options of module mounting structure like tool, portrait, or 4 modules, one on the above in landscape. Other parameter which affects this module orientation is its alignment. Like if you go with landscape arrangement with arrangement of rails, it gives better alignment than portrait arrangement in terms of aesthetic perspective. And then another thing is tonnage. So we have done various kinds of permutations and combinations, and we could find out there are some configurations of modules, like we have done 4 landscape in crystalline modules, 250 watt crystalline modules, which gives optimum structure using rails and which gives better alignment also. Again, in terms of MMS only, this another important thing comes is base spacing. Like base spacing is spacing between 2 vertical posts of module mounting structure. It is also an important factor because more the spacing between 2 supports, higher will be your rails or purlins, and which will increase your tonnage. Now this also plays an important role in terms of soil characteristics. If soil is hard, it will need very soil is hard, you can have this base spacing longer because your reactions, whatever high may be the reactions, the foundations can be designed very easily for hard strata. But if the same thing happens in loose soil, which like areas which have water bodies nearby, like a river, nearby a river bed or something, wherever the soil is very loose, there you cannot afford to have higher base spacing or longer base spacing, because longer base spacing means more reaction on the foundation. So in those cases, what we do, in those cases we try to minimize the number of foundations by increasing the base spacing, because I can have minimum number of foundation in loose soil, but I cannot have multiple or more foundation in loose soil. So in hard strata, I can go with lesser spacing and higher number of foundations, because foundation cost is less in hard strata, and in loose strata I will recommend to go with less number of foundations with longer base spacing. Now coming back to my presentation, optimization of tilt and pitch. It is, if you see in this figure, what is tilt angle and what is pitch. Tilt angle is the inclination angle at which your modules are being placed, and the plane area is generally called plane of array. And pitch is the center to center or edge to edge distance between 2 module rows. So increase in tilt will increase in shadow length. Obviously the increase in this tilt will make this edge or height of the top part of the module to go high, and that will cast shadow to the next row. So increase in tilt will increase in your module. However, increase in tilt will give you more generation. Again, there is limitation to increase in tilt, because if you see this graph, with increase, and the tilt angle is again function of location, where you are located on Earth. So according to done this analysis for one of our sites in North India, and if you see here on x-axis there is on x-axis it is yield, annual yield of the solar per megawatt annual yield of the PV plant, and these are the y-axis is annualized yields of the solar plant per megawatt, and x-axis is the various tilt angle. And if you see, first column is various kind of various generation for that 24 degree altitude, latitude, At 18 degrees the generation is 1702. As I go on increasing the tilt angle, my generation goes on increasing. However, after 24 degrees further, if I increase the tilt, the generation goes down. Thus your tilt angle should be in line with your position on Earth. Now regarding pitch, if I increase pitch, the spacing between two rows, the probability of southern side module and module mounting structure casting shadow on northern side module is lesser if I increase pitch. But then again there is a limitation on increasing pitch, because the more pitch I put in, I invest in more land. So if you see this further analysis, we have done it for pitch of 6.5 meter, 7 meter, 7.5 meter, 10 meter and so on. So if you see for this land which is in northern part of India, the optimum pitch which we recommend, or which is around 24 degree, and the pitch tilt is 24 degree and pitch is 7.5 meters. Beyond this also I can increase the pitch. So if you see the number of acres of land which I require for per megawatt of plant is, see, with 6.5 meter I have 3 acres of land. With 7 meter pitch I increase the land per megawatt 3.4 acres. With 7.5 it's further increases. So even if I am getting better generation at higher tilt, at higher pitch, but I am investing more in land, and everybody knows how precious land is nowadays. So you will have to have a combination of tilt and pitch, optimum combination of tilt and pitch, by which you can maximize the generation with minimum land and minimum shadow losses. This is again another tilt versus pitch analysis. So there are three tilt angles. Black one is 12 degree, green is 14 degree, and light green is 16 degree. And if you see with respect to pitch, increase in pitch, your generation is going on. And if you see the land area is increasing. Now this was with some different module configuration. This was with our optimized 4 landscape crystalline module configuration. This is with thin film kind of configuration, wherein the land requirement is higher, around 5.5 acre per megawatt. Sorry, 4.9 acre per megawatt, and with increase in pitch, it goes on increasing till 8 acres. So the planner or designer has to take optimum balance between tilt and pitch, and which he can do by running multiple number of PVC reports and then getting the annualized generation figures and plotting them in this way. So you can present the data in this graphical format and come to a conclusion which is the optimum tilt and pitch. Now coming to shadow analysis, purpose of shadow analysis is to estimate the length of shadows or the items which can cast shadows on modules, and which in turn will affect your generation. So various components of solar plant which we consider for shadow analysis is major is the module mounting structure, inverter control room, compound walls, street light, lightning arresters, and nearby structures like trees or buildings. So we consider all this height of all these equipments or all these components while planning array layout. And the tools which are available to ascertain this shadow analysis is PVSys 6.3, Trimble SketchUp, priorly called as Google SketchUp, and so Suneye instrument. So in PVSys you can construct your own plant in the PVSys software and have the PVSys analysis done as per your array layout, but it is very cumbersome or time consuming job. So you can do it, but it will take time. So, or else what you can do it for one cluster and then replicate it for other clusters if the nearby surrounding does not having any kind of shadow or shadow casting structures. SketchUp Pro gives like 3D kind of an pictorial representation of your plant, and you can have shadow lens at longest sunny days and ascertain your shadow lens and do your area planning. In Suneye, I hope most of the participants are aware of this instrument Suneye, wherein you capture the horizon around your plant by taking the SANAI instrument on site and then capture images at various locations in the plant. So SANAI will capture the horizon images and then put them, integrate them with the sun path at that area, because SANAI is with inbuilt GPS locator, so it identifies the location, and once it captures the horizon view, it superimposes it with sun paths throughout the year, and then you can identify in which month the shadows what will be the length of those shadows in respective months of those particular items. So coming to the module mounting structure, what kind of shadows module mounting structure we can have is inter-row shadow and inter-table shadow. So what is inter-row shadow? Inter-row shadow is shadow between the two rows. Like say these are the north facing rows, so row 1 and row 2. So since we are into northern hemisphere of the earth, we mount or we keep module aligned or sloping to the south. So south side module is casting shadow on northern side of module. Now here your pitch comes into play. If you increase this pitch, the amount of shadow or the time from which the shadow will start. Like say this shadow will be prominent in the morning till 8 o'clock, 7 or 8 o'clock, and after 4 p.m. in the evening. So if you want to even still avoid this kind of shadow, you will have to have very high pitch which will eat up your land. So you can have optimized balance between this pitch and your shadow loss. You can simulate this shadow loss in PVCs. So this is inter-row shadow. Now this shadow again becomes very prominent if the land is sloping towards north. Ideally the solar plant land should be sloping towards south. If the land is sloping towards north, this shadow problem becomes more severe and you will have to take care of it. So while you are planning your array layout, make sure your land is sloping towards south, and which you can do by having contour survey of site before doing any kind of array layout. And contour survey will also help you in identifying tall structures within the plant boundary or nearby the plant. And what second part I was talking was inter-table shadow. So this is shadow between two tables east to west direction, in east to west direction. If in case the two tables are at different heights, see what happens when you do actual plant layout, every time flat like a football ground, it may be sloping from east to west or west to east. In these cases what happens, we can do grading, but then grading becomes a very costly affair, and in those cases what we do, we follow the land terrain. Now while we follow the land terrain, what happens, the modules on the higher side make cast shadow on the lower side of tables during morning. So this will happen either in morning or in the evening, depending on which side the slope is. If the slope is from west to east, it will happen in morning. If the slope is from east to west, it will happen in the evening. So this, now to avoid this, what we can do, either we can do a grading wherein we can make sure that the height difference is not much, or what you can do is keeping these two tables apart from each other, so in such a way that those modules do not cast, the one table cannot cast shadow on the other table. So generally the thumb rule is in shadow analysis is, if this difference is suppose x, level difference between table 1 and table 2 is suppose x, then you should have minimum table spacing of 2.5x. So you can have this kind of arrangement in your array layout. So inter-row shadow and inter-table shadow. So both kind of shadow analysis you will have to do while you are planning your array layout. And again you will have to do this techno-commercial analysis between grading and land and the kind of revenue loss you are incurring based on this shadow loss, because whenever we are talking of these shadows, these are the shadows which will be prominent before 8 AM and after 5 PM. So during these periods your irradiation is also very low, around less than 300 watt per meter square. So in trying to avoid these shadows, you may incur in a very high cost of land, which is a very high in terms of saving, the savings might be negligible, because whatever saving you will get by doing this exercise are very less, because this shadow problem is in early morning and late evening when the generation is very less. So you need to do this techno-commercial analysis before taking any kind of decision. Second is inverter room. As Sanjay has earlier showed some of the array layouts or plants, you would have noticed the inverter control room. There is vast difference between inverter control room or power conditioning unit, so power conditioning station, and the modules. This is majorly because of the control room being tall structure. See, the inverter height itself is around 2.5 meters, and then the top clearance and plinth elevation of plinth for avoiding water logging. So ultimately control room height goes around 4.5 to 5 meters. So this tall structure can cast shadow. So once this structure is 5 meters, this can cast shadow up to 15 meters in evening and morning. So you need to plan space on east and west side of the control room, and also probably the control room should be on the northern side of the modules. If it is at the center, you should plan accordingly at least 10 meters from north to south point of view between modules and the control room. So here you can see how morning and evening shadows are affecting modules. And the major problem with this shadow is suppose a combiner box is having 5 tables, which is having suppose 4 tables which are having 16 strings. Once a shadow falls on second table during evening, the performance of the strings in this table get affected, and simultaneously performance of all other 4 strings also get affected. So it's not only the question of 1 row or 2 row, it is a question of combiner boxes connected to that string. Suppose these 16 strings are connected to a combiner box. Even if a shadow on single string can affect performance of all 16 strings of that combiner box. So from that perspective, your shadow analysis is very important, because shadow on single string or single row can affect your entire combiner box. Then what are the other equipment which we place into the solar plant is weather station, watchtower. This is again a specific requirement by for safety or pilferage point of view in Indian scenario, wherein we put fence, even though along with fence we put watchtowers to have surveillance in night time also, wherein you can have a searchlight kind of thing. So all this, say weather station is around 3 to 4 meter tall, watchtower 5 to 8 meter tall, street light 5 to 6 meter, nearby trees means we have taken 7 to 15, but it depends on situation to situation. Lightning arrestor is again a major equipment which you need to place on top of control room to have its coverage area radius. So even though it is written 4 to 5 meter, it is actually 5 meter of control building, and on top of that, suppose it is 1 or 2 meter of that spike. So ultimately it goes to 7 meter tall structure, and even the compound wall. So all these components generally are going to cast shadow on modules which are around 2 meter tall structures. In a typical solar plant, generally top side of the module is around 2 to 2.5 meter tall. And you should also not try to increase this height, because this is again related to the module cleaning. The more tall module mounting structure you opt for, it will be difficult to clean them. So these are the items which can cast shadow. So you will have to plan space between modules and these items so that they do not cast shadow on your module mounting structures. So these are the typical screenshots of Google SketchUp or Trimble SketchUp Pro software, wherein you can ascertain the length of shadow on various days of the year. The software will simulate. This is the street light shadow analysis. So if you see the shadow is on eastern and western part at some incline angle. So this angle you can find out from Google SketchUp Pro or even from PVSys, and then you can mark these lines on your array layout and then keep this area falling within this shadow line as space vacant, and then plan modules in rest of the areas. Similar way is the compound wall. Compound wall also cast shadows. The compound wall is generally 2 meter high, so it can cast shadow about 4 to 5 meters. So generally what you should plan is, and always there is a road next to compound wall, so you should generally plan a road and drain which will run along this compound wall and which will give you around clearance of 6 to 8 meters between modules and compound wall to avoid shadowing. I think that's all. I think if you have any questions, you can put on to this chat box, or you can mail to me on Sutar, SUTAR dot Suhas, SUHAS numeric 2, sutar.suhas2 at mahindra.com. I will just text it to all. Or this panelist will circulate it, my email ID to all. Thank you. Sanjay, are you there?
Thank you, Suhas. I think we can understand this is a vast topic, and there's a lot of things which goes inside. It is not only the technical side, but a lot of financial parameters also come. As you rightly said, that we need not to take the module height too much, because it may be subjected to the wind pressures and the stability of plant.
Right.
But finally it comes to the techno-economics. On one side it is the technology, and on other side it is a financial decision. So yes, I agree to you that yes, shadow is important, but it is coming in the morning when the 300 watt per meter square is the solar radiation. Then you have to analyze that how much are these shadow losses vis-a-vis your incremental cost of land. So if it is a place like Punjab, you can't afford to have a 3.5 meter of pitch because the land is very costly. But if it is a place like Rajasthan, you can have obviously various factors. So you have to consider that if you are taking one design, finally this design needs to be evaluated on the basis of the economic implication of not only on the economic, I'm just using one of the implication is the economic implication, but there are other factors also. For example, as Suhas mentioned, that you have to take your tractor for cleaning. So even if shadow is not being casted, you can compromise for the shadow casting, but how you will take your water tanker in between the arrays? It may damage your modules if the distance is very narrow. So you have to take care of the operational aspects as well, apart from the design aspects. So certain things which are necessary apart from the design aspect itself, which matters a lot. Maybe I could not get through chat box the questions from the audiences, but certainly we will be more than happy to have your questions at a later date, and we will address this presentation. We will be putting on our website, and this might be available at the Mahindra's website as well. We are thankful to being partner with Mahindra to do this webinar, as they have acted as a presenter and knowledge partner to this topic, which is a topic which is much more relevant because a lot of capacities are going to come up. What we have seen when I shared some of the things is we have been doing a lot of learning while doing these projects. We thought that solar projects are easier to do. It's very simple. Everything is visible. But when you go to the deeper aspect of this, you will find that it is not that easy exercise. It needs a deeper analysis before you act on the things, because once you commit a mistake, in a solar field there are 50,000 modules and some 10,000 structures. How you will do those corrections? It is impossible. So you have to be very, very careful while starting the layout right from the start of your project, that is the layout planning. And that's the reason we felt that this topic has a relatively lower understanding from the participants, and it will make a lot of sense if we share our understanding about the solar plant layout strategies with our listeners. We thank you for participating, and we will have many more coming up presentations as a part of this webinar series. And we feel encouraged once you ask us questions, and any thing which goes beyond this also you can ask me or Suhas. The details are available to you. So here we close the webinar. Thanks everybody for attending this webinar.